Hello, we are in Chapter 7, Section 7.4, Logarithmic Functions. In this video, we're gonna go over problem number 6, in which we are to rewrite equations in exponential form and then solve for x. In part A, x is the input of the logarithmic function, so we first rewrite in exponential form the base is 2, the value of the logarithm, that means the exponent, is 4, and then, as I said, the input is x. So the exponential form is 2 to the 4th equals x. And that immediately gives us the value for x to be 16. In part B, x is also in the input of the logarithm. The base of the logarithm is 10, so it will become the base of the exponential. The value of the logarithm, that means the exponent, is negative 2. And that input is x. So the exponential form will be 10 to the power of negative 2 equals x, again immediately giving us the value for x to be 1/100th. In part C, x is on the other side of the equation, and it's simply equal to log base 2 of 32. So the exponential form of this equation, with the base of 2, the value of the exponent x, and the value of the exponential 32 will be 2 to the power of x equals 32. That's an exponential equation that we solve for x by asking what exponent imposed on 2 results in 32. And that exponent is 5. 2 to the power of 5 is 32. Now in part D, x is in the base of our logarithm. So in addition to finding what that base is, we need to make sure that it is greater than 0, because bases of logarithms must be greater than 0 and also not equal to 1. So the base is x, that becomes the base of the exponential. The exponent, that means the value of the logarithm, is 2, and then the value of the exponential, which is the input of our logarithm, is 9, resulting in the exponential form x squared equals 9, again with x greater than 0. That's a simple quadratic equation. If x squared is 9, then x is plus or minus the square root of 9, which is plus or minus 3, but with the constraint that x must be greater than 0, we only get x equals 3. In part E, again, x is on the right-hand side of our equation. The base of the logarithm is 3, that becomes the base of the exponential. X is the value of that logarithm, the exponent, and then the value of the exponential, the input of the logarithm on the left-hand side, is 1/9. So we get the exponential form 3 to the power of x equals 1/9. So we're asking the question, what exponent imposed on the base of 3 results in 1/9? Well, first of all, it's a reciprocal, so our exponent must be negative, and 9 is the second power of 3, so we get the exponent of negative 2. Part F is very similar to part E. We have logarithm with the base of 2, that becomes the base of the exponential, the value of the logarithm, the exponent being x, and the value of the exponential, the input of our logarithm, is 1. So the exponential form is 2 to the power of x equals 1, and we're asking what exponent imposed on the base of 2 results in 1, and that exponent is 0, because any non-zero number raised to the power of 0 results in 1. In part G, x is again in the base of our logarithm, and that becomes the base of the exponential. The value of the logarithm is 1/2, that becomes the exponent of the exponential form, and the input of the logarithm is 7, that becomes the value of the exponential. So our exponential form is x to the power of 1/2 equals 7, but since x is in the base of the logarithm, it must be greater than 0. Recall that x to the power of 1/2 is really the square root of x, so our equation really is the square root of x equals 7. We square both sides to get x equals 49, and that is our solution. Finally, in part H, we have log base 8 of 8 equals x, 8 is the base of the logarithm, that becomes the base of the exponential. X is the value of the logarithm, which becomes the value of the exponent in the exponential form. And the input of the logarithm is 8 and becomes the value of the exponential in the exponential form. So we get the exponential form to be 8 to the power of x equals 8. So we're asking what exponent imposed on the base of 8 results in that 8. And obviously that exponent is 1, since anything raised to the power of 1 results in itself.